Hello, today we're going to talk about structure 3.2.5, which is all about the IUPAC naming for organic compounds. Okay, so IUPAC stands for the International Union of Pure and Applied Chemistry. It's like a governing body that decides all of the rules for how we name different chemicals. And for organic chemistry, the first thing to do is figure out the number of carbons present in the main chain. Now, some people will call that main chain the stem or the parent chain, but that's going to determine the name of your hydrocarbon or your organic compound. If there's one carbon, the prefix will be meth, 2 will be eth, 3 is prop, 4 is bute, 5 is pent, and 6 is hex. Then the suffix is determined by the type of bonding. So if there's single bonds, it ends in -ane. If there's at least one double bond, it ends in -ene. If there's at least one triple bond, it ends in -ine. So that's where you get things like propane or propene, ethine. So you'll wind up with different compounds based on that naming structure. All right, once you figure out your main chain, then you have to see if there's any substituents. Substituents is the word. They can be in the form of branches. So let's say we have our carbon, and our main chain looks like this, and I have a branch. So you're going to see, and the rest will be hydrogens, like this. And so you need to count the number of carbons in your main chain. There are 4 carbons in our main chain, so we've got bute. Then you have to number your carbons. The way that you number your carbons is you go to the end of your main chain that is closest to the branch, or closest to the substituent or to the functional group. So in this case, I have 2 ends of my branch. This end is closest to the chain, so that's my carbon 1. And then you just go in order, 1, 2, 3, 4. So the branch is off of the second carbon. So I need to say that the branch is on the second carbon. It's 2-methyl bute, and it's only single bonds, so ane, 2-methyl butane. Let me do another one. If I have I'm just going to do the carbon skeleton here, like this. Ooh, that's a good one. What if I have this? Well, it almost looks like the main chain is here, but that's not my longest chain. You always have to find the longest set of carbons in a row. And that actually is this right here. And the branches are right smack dab in the middle, so it doesn't matter which end I start numbering on. I have 1, 2, 3, 4, 5. If I numbered the other way, it would still be 1, 2, 3, 4, 5. The branches would still be on carbon 3. So in this case, I have 2 sets of single carbon atoms coming off of the main chain. So I would say that's dimethyl, 2 sets of 1 carbon coming off of the main 5 carbons. And let's say they're all single bonds. And then we would use the number 3 because they're both on the 3rd carbon. It would be 3,3-dimethyl pentane. So we're still going to use those same prefixes for branches, meth, eth, prop, bute, pent, and hex. But you'll use this YL on the end of that to denote that it's part of the branch. And you have to use numbers to say where those carbons are. If there's more than one branch, then you'll use the same, prefixes, sorry. So if there's like a di, tri, tetra, if there's 2, 3, or 4 of the same size branch sticking off of the main chain. And so that's how you would name a hydrocarbon with branches. Okay, so now let's say instead of a branch, you have a halogen as your substituent. You're going to use a prefix kind of like you did with the like methyl ethyl propyl groups. So let's do an example with pentane as our parent chain. And let's say, for example, there's a bromine. And so we would number our carbons like this, because you always start at the end that's closest to the substituent. So the bromine's on the second carbon, and so you would say it's 2-bromopentane. If you had 2 bromines, I put a 2. If you have 2 bromines on the same carbon there, you would say that's 2,2-dibromopentane. You could even have like this, where you have the bromines on different carbons, 2,3-dibromopentane. You could also have a compound like this. The parent chain has 3 carbons, so prop, but there is a double bond, so that's a propene. And the chlorine's on the second carbon over, so 2-chloropropene. So let's talk about the hydroxyl functional group. Hydroxyl is OH. They form the alcohol class of compounds. So if you have an OH as your substituent, let's put it in the middle here just to show you. You're still going to number your carbons from whichever end is closest. This side it doesn't matter because it's right in the middle, so it's 1, 2, 3. There's a difference in how you name it though. Instead of putting it at the front, because it's changing the class of compound, you're going to change the ending. So this is a propane as our parent chain, all single bonds. But instead of ending in E now, we're going to make it propanol. So alcohols end in -ol. But wait, we have to tell where the OH group is. So we would say it's propan-2-ol. I know it's kind of weird putting a number in the middle of a name, but the 2 tells us where the alcohol group is. Just like in our previous examples, we put the number right in front of the thing that we were numbering. Let me give you another example. If I have like this, you always number the carbons from the closest to the substituents. So it would be this end. So this one would be, bute, because there's 4 carbons. So bute. And because they're single bonds, 2,2-diol. Butane 2,2-diol. I do want to take a moment to point out something that I didn't talk about earlier, which is the locations of if there's a double or a triple bond. So let's say, for example, I have a butene like this. This would be a butene. But how do I distinguish this butene from this butene? The double bond's in a different spot. Well, you're still going to number from whichever carbon is closest to that double bond. But in this case, you would say, okay, the double bonds between carbon 1 and carbon 2, whichever number is smaller is what we're going to use. So this one is bute 1-ene because it's attached to carbon 1. This one is between 2 and 3, and you always use whichever carbon's smaller. So this one is bute 2-ene. And it works the same way for triple bonds with -ine. You put the number in front of the thing that you're representing. Now let's talk about the carbonyl functional group. I have a C double bond O. Now remember, this can form 2 different functional groups. It could be an aldehyde, or it could be a ketone where there's carbons on both sides. So aldehydes are always at the end of the chain, and their names end in -al. Ketones are always somewhere in the middle, and their names end in -one. So let's say I have something like this. This would be butanal because it's 4 carbons, single bonds, and an aldehyde. Let's say I have like this. Okay, so that's a ketone. But I need to be specific because this ketone might be different from this ketone, right? So you need to be very specific in your naming. So this would be pent ane because it's single bonds. 2-one, pentan 2-one. Remember, you always number the carbon from whichever side is closest to that functional group. So pentan 2-one. Now, carboxyl refers to the C double bond O with an O as well, and there are 2 versions of that. There's an OH, which is a carboxylic acid, and if that's attached to another carbon, it is an ester. Okay. So carboxylic acids always end in oic acid, and they're always at the end of a chain. So you would have something like this, 3 carbons, so prop, single bonds, and oic acid, propanoic acid. Esters are a little bit different. They do end in O8, but because we've got carbons on both sides, I need to be very, very specific with my naming. Whichever side is closer to the single bound oxygen, that's going to go first. So let me give you an example. Okay, let's do that. And this again, I'm just eliminating the extra hydrogens so it's easier to draw. Whichever side is closer to the single bound oxygen, you count that first. Single bound oxygen. That's only 1 carbon. So I'm going to say methyl. It's 1 carbon attached to that. Then I count the other carbons. It's 3. So prop. And it's single bonds, so an. O8. There's the indicator for the ester. So you always name the one that is next to the single bound carbon, and then you count the rest of the carbons for the rest of the name. Now you should be able to recognize names that have amines and amides in them, but you won't necessarily be asked to name them for yourself. Amines have the ending amine in them, so like CH3NH2, that would be methylamine because it has a single carbon attached to an amine group, methylamine. Amide, so you could have something like this. So this would be ethanamide because the 2 carbons, single bonds, and then the amide, the C double bond O next to the N, ethanamide. So again, you don't really need to be able to draw them yourself or name them yourself. Just recognize if it has amine, you know it's got that amine group. If it has amide, you know it has an amide group. But one thing that you should be able to do with amines is tell whether it's primary, secondary, or tertiary. So if I have, I'll just use C. So if I have that, remember nitrogen can form 3 bonds. If I just have 1 carbon attached to the nitrogen, that is called a primary amine. If the nitrogen has 2 carbons attached, that is called a secondary amine. And if I have all 3 places taken up by carbons, that is a tertiary amine. You can also classify some of the other functional groups as primary, secondary, or tertiary. So like if I have a halogenoalkane and I put a chlorine on the first carbon, that would be primary. because the carbon that it's attached to just has one additional carbon. If I put the chlorine in the middle, though, that would be a secondary halogenoalkane because the carbon it's attached to has two additional carbons. And you could even have a tertiary halogenoalkane like that. You could do a very similar thing with alcohols too. You could have the OH attached to a carbon with three other carbons. It'd be a tertiary alcohol. That would be a secondary alcohol. Or if I put it on the end, it would be a primary alcohol. So you can do that primary, secondary, tertiary with alcohols, amines, or halogenoalkanes. So ethers and phenols, again, you won't really be asked to name them yourself or like be able to draw the structural formula from a name, but you should be able to recognize the functional group. So an ether will have an oxygen in the middle. And the way that's named is always going to be the smaller number of carbons. So this one is meth, is a smaller one. So methyl. Meth comes first. And then you have an oxygen in the middle, so you have oxy in the middle of the name. And then you name the rest of it. 2 carbons, single bonds, methoxyethane. So if you see oxy in the middle, you know there's an ether. And then phenyl is that benzene group attached to something. And so let's say I just have this compound here. When you have that phenyl functional group, your names are going to end in benzene because it has a benzene ring attached to something. And that something here is a methyl group because it's a single carbon. So this is methylbenzene. Okay, so let's do a couple examples. We're going to give the class and the IUPAC name. This one is going to be an alkane. We have a CH3, CH2, CH with a CH3 attached, and another CH3 at the end. So now I'm going to fill in those other hydrogens like this. Actually, I'll even put the hydrogen here. All right, so there's your structure. The main chain has 4 carbons, and I have all single bonds, so it's a butane. And you always number the carbons starting at the end closest to the substituent. So this is carbon 1, carbon 2. So this is a 2-methyl butane. This compound here is a carboxylic acid. Remember that you can tell very quickly that it's a carboxylic acid with that COOH. But if I were to draw this really quick, there's our carboxylic acid. So this carboxylic acid is on the middle of a compound, which is kind of weird. But it becomes much easier to name if you consider this as our main chain and this as a substituent. So if our main chain is 3 carbons, that would be propane. But the end is our carboxylic acid, oic acid. And the methyl group, if I start at my carboxylic acid, that's carbon 1, and carbon 2 is where the methyl group is coming off. So this is 2-methyl propanoic acid. Okay, structural formulas for the following molecules. I have methanoic acid. The prefix meth means 1 carbon, and it has an oic acid, so carboxylic acid. And then you just fill in the additional hydrogens. There's one more spot for hydrogen there, and that's methanoic acid. The next one, hex 3-ine. Hex means 6 carbons. Okay, and if I were to count them like this, 1, 2, 3, 4, 5, 6, the 3 would indicate that it's between the 3 and the 4, and it's a triple bond because it's Y-N-E-ine. And then you would fill in the additional hydrogens. There are 3 additional spaces for hydrogen on the first carbon, 2 additional spaces on the second, none on the third and fourth, 2 on the fifth, and 3 on the last carbon there. And that is hex 3